Hi all, this is the first video I'm gonna upload on Unit 6, and it's gonna discuss all about uncertainties. Hopefully it's gonna be a short video. I'm still thinking about how and if I want to talk further about the Unit 6 core practicals, given that I don't have any equipment in my disposal, but I'm still thinking about it. So anyway, let's get started. So this video is going to be about uncertainties. So I will try to present everything you need to know, hopefully, on uncertainties. So let's start with basics. So for a single measurement, the absolute uncertainty is half the deviation of the instrument used. That is the instrument used to make the measurement. So for example, if I tell you that mass is 25 kilograms, then we have to add plus or minus 0.05 kilograms, because usually scales measure up to 0.1 kilograms. So they tell you, for example, I am 82.1 kilograms right now. So if the if the smallest deviation of the instrument is 0.1 kilograms, you take half of that, okay? And this is your absolute uncertainty, and it's called absolute because it's measured in the same units as the measurement itself. So this is the absolute uncertainty. I'm gonna box this, okay? Now, if we take multiple measurements, so if we take multiple measurements of a physical quantity, then the absolute uncertainty is taken as the half range, sorry for my spelling, the half range of the measurements. So if we use the same scales as I mentioned before to measure the mass of something, and we find that the mass is 25 kilograms in one measurement, 24.9 in another, 25.1 in another, etc., then you don't take the half the deviation of the instrument as the absolute uncertainty, but you take the half range. So let's write this down as an example. So if we measure the mass, if we take measurements of a mass, okay, and the first measurement is 25.1 kilogram, then the second measurement is 24.9 kilograms, and the third measurement is 25.4 kilograms, okay? Then we take the average mass as, sorry, we take, what am I trying to say? Let's step back, sorry. Then the average of these measurements is simply adding these three values, okay? And dividing by 3. So the average mass for these measurements is 25.13 kilograms, okay? So notice that this has nothing to do with the smallest deviation of the instrument anyway, okay? And then for the absolute uncertainty, we take the half range. So the half range, the range of these measurements is from 24.9 kilograms to 25.4, so the extreme values, okay? So we take 25.4 minus 24.9, so that's your range, and then you divide by 2 to find the half range, okay? So this is 0.25 kilograms, okay? And this is the largest, and this is the smallest measurements, okay? So in this case, the mass should be coded as 25.13 plus or minus 0.25 kilograms, all right? And this is it for absolute uncertainty, okay? So if it's a single measurement, you take half the deviation of your instrument, and if it's a range of if you have multiple measurements, so statistics are involved, then you take your measurement to be the average of those measurements, and the absolute uncertainty should be the half range of those measurements. Okay, I hope this makes sense. If it doesn't, ask me in the comments. Now, percentage uncertainty now. Okay, now let's talk about the percentage uncertainty. So this is found by taking the absolute uncertainty dividing it by the value itself times 100%. Okay, so if we go back to the two masses we dealt with, so for a single measurement we said that our mass was 25 plus or minus 0.05 kilograms. Okay, so the percentage uncertainty, and I'm gonna write it like that, is simply 0.05, which is the uncertainty, over 25, which is your measurement. And notice that here you're dividing kilograms with kilograms, therefore this cancels and this is a pure number, okay, times 100%. So the percentage uncertainty is simply 0.2%, okay? And in the case where we took multiple measurements and found the average and then the absolute uncertainty from half range, the mass was 25.13 plus or minus 0.25 kilograms, and the percentage uncertainty is now 0.25 over 25.13 times 100. If you do this, you find 0.99% or 1%, pretty much, okay? All right, is there anything else I want to talk about here? I think not. Okay, so we have two types of uncertainties, pretty much, the absolute uncertainty and the percentage uncertainty. Now let's go talk about the somewhat more difficult task of compounding uncertainties, okay? So compounding uncertainties. Oops. All right. Okay, so there are multiple cases. Actually, I think 4 cases. It's not multiple, okay? So I'm gonna talk about all those 4 cases, and then I'm gonna work out 2 examples that will help clarify what's going on. So first case is when you multiply, oops, something's wrong with my spelling today. So multiply or divide by a constant. Okay, so let's say, okay, for example, the radius of a circle is 4.3 plus or minus 0.2 centimeters. Okay, so let's say that someone gave you this measurement and asked you to find what would be the value of the diameter and what would be the absolute uncertainty of the diameter. So recall that the diameter is simply 2 times the radius, right? So you just multiply by 2 pretty much in this case. So D is 8.6 plus or minus 0.4 centimeters. Okay, simple as that. Or another example, maybe someone tells you that the time for 10 oscillations is 40.4 plus or minus 0.5 seconds. Then what is the period? Then, okay, the period should be t over 10, right? So again, you just divide by 10. So you take this measurement and you divide by 10, okay? So the period will be 4.04 plus or minus 0.05 seconds. Simple as that. So the general rule, and I'm gonna use a red color, is multiply or divide the absolute uncertainty by the constant. Okay, so this is a simple case. If the physical quantity of interest is some multiplication of another physical measurement, then and this physical measurement comes with an absolute uncertainty, then to find the absolute uncertainty of the new quantity, you just multiply or divide by that constant, okay? All right, second case. Raising, and I'm gonna write in parentheses a physical quantity to a power. Okay, so let's say that we measure the length of something and it's 182 plus or minus 0.5 centimeters. Okay, so to work with powers, so let's say, okay, that the length of the side of a square is this, okay, and then you want to find what's L squared and what's the uncertainty in L squared, okay? So to work with this, you need to take a few steps. So the first step when you work with powers is to take the percentage uncertainty of your measurement. So in this case, it's 0.5 over 182 times 100, and you find 0.61%, okay? Then you write that L is 182 plus or minus 0.61%, okay? And you don't write units now, okay? Or maybe if you want to write units, you put the centimeters there. So centimeters there, right? Then L squared is simply 182 squared, which gives you 6724. So 6,724 centimeters squared, plus you multiply the percentage uncertainty of your initial measurement by the power. Okay, so the power here is 2, so you multiply 2 times 0.61%. Okay, so in this case you have 6724 centimeters squared plus or minus 1.22%. Okay, so now you have the percentage uncertainty. What if someone asks you what's the absolute uncertainty? Okay, so the absolute uncertainty, to find the absolute uncertainty in L squared, you multiply 1.22% times 6724, and this gives you 82 squared centimeters. Okay, so L squared is also 6724 square centimeters plus or minus 82 square centimeters. Okay, so the rule is to multiply. So when you deal with powers, you multiply the percentage uncertainty by the power. Okay, so that's the rule. So when you deal with powers, you first have to find the percentage uncertainty, multiply it with the power, and if you want to find the absolute uncertainty, then you multiply the percentage uncertainty with whatever your measurement is to find the absolute uncertainty. So it takes an extra step, pretty much. Okay, this was the second case. Then, okay, third case is adding or subtracting two variables. So let's say you have the first variable 10.1 plus or minus 0.1 centimeters, and then the second one is 14.3 plus or minus 0.4 centimeters. Okay, so the total length is the length A plus the length B, so that will give you 24.4, and then plus or minus what? You just add, okay? You just add the absolute uncertainty, so 0.5 centimeters, okay? Then let's say that you want to find a second length, which is the subtraction of LB minus LA. Then what do? So you subtract them and you find 4.2 plus or minus what? Again, you have to add them, okay? So 0.5 again, okay? So the rule is when you add or subtract two variables, okay, that come with two absolute uncertainties, okay, you just add the absolute uncertainties. So add absolute uncertainties, that's the rule. Okay, and the fourth case is multiplying or dividing variables. Okay, so let's say that I have this rectangle, and for this side we know that the side is 3.21 meters plus or minus 2.6%, so we are using the percentage uncertainties here, and then this side is 5.56 plus or minus 2.5%. Okay, so the area is simply the multiplication of this number and this number, right? And I forgot the units, so that's meters. So the area is 17.85 meters squared. Plus or minus, what do? We add the percentage uncertainties, okay? So you add this and you add that to find the percentage uncertainty of the new quantity, which is area in this case. So the percentage uncertainty is 5.1%, okay? So when you multiply or divide variables, you first have to find the percentage uncertainty, okay? And then you add percentage uncertainties. If you want to uncover the absolute uncertainty, then all you have to do is to multiply the percentage uncertainty with whatever you found to find the absolute uncertainty. And let's do one more example. Velocity is distance per time, right? So let's say that my distance is 10.5 meters plus or minus 4.1%, and my time is taken to cover this distance is 2.35 seconds plus or minus 8.7%, okay? Now, the velocity is the division of the two, so 4.6 meters per second, and then plus or minus, again, you add. So you add the percentage uncertainties again. So you, by adding them, you find 14%, okay? And that's your percentage uncertainty, and if you want to find the absolute uncertainty, you multiply the 14% with 4.6 to find the absolute uncertainty. So when you multiply or divide physical quantities, you add the percentage uncertainties. So the rule is add percentage uncertainties. Okay, let's go see an example I pulled out of a past paper, but I don't have I didn't write down the past paper I took this from. So let's go with it. So I have a quantity S given as 16.83 plus or minus 0.02 millimeters, which for for some reason I have this converted to centimeters, so let's do 1.683. And to convert millimeters to centimeters, you divide by 10. So you also divide the absolute uncertainty by 10. Okay, so this is what the value is in centimeters. Then you have D as 8.55 plus or minus 0.04 millimeters, which if I divide by 10 is 0.855 plus or minus 0.004 centimeters. All right. And then I have some quantity A written as the square root of 3 over 2 s squared. So this is some area minus pi over 4 d squared. Okay, so the task is to show that the absolute, let's write it down, the absolute uncertainty in A is 0.01 centimeters squared. Okay, so before we do this, because it takes some time, we have quantities raised to a power. Okay, so first of all, we need to find the percentage uncertainties of those quantities to begin with. So the percentage uncertainty in S is 0.002 over 1.683 times 100%, so 0.12%. Then the percentage uncertainty in S squared is 2 times that, right? So 2 times 0.12% gives you 0.24%, okay? The percentage uncertainty in D is 0.004 over 0.855 times 100%, which yields 0.47%, okay? So the percentage uncertainty in D squared is 2 times 0.47%, which is 0.94%. Okay? Right, now, how can we find the absolute uncertainty in S squared? We multiply the percentage uncertainty in S squared with S squared itself, okay? So the absolute uncertainty in S squared will be 0.24% times S squared. What is S in centimeters? Yes, in centimeters is 1.683. So 1.683 squared, which yields 6.8 times 10 to the negative 3 centimeters squared. Then the absolute uncertainty in D squared is 0.94% times 0.855 give me a second, I got myself confused. Wait, yes, 0.855 because we're using centimeters. Okay, the squared. So this is 6.87 times 10 to the negative 3 squared centimeters. Okay, then remember that A is given as the square root of 3 over 2 times S squared minus pi over 4 times D squared. So the absolute uncertainty in A will be square root of 3 over 2 times the absolute uncertainty in S squared, which we found, plus, remember, we add, okay, plus pi over 4 times the absolute uncertainty in D squared, so 5.89 times 10 to the negative 3, which is the square root of 3 over 2 times this, and then plus 5.39 times 10 to the negative 3, which is pi over 4 times the absolute uncertainty in D squared, gives you exactly 0.01 squared centimeters. Okay, so this is a difficult example. But to make it easier, again, we have quantity squared. Okay, so this prompts you to directly take the percentage uncertainty of the quantities given to you. Okay, and then you have the subtraction between, you can treat this as two variables, right? So if you subtract two quantities, you add their absolute uncertainties. And then because those absolute uncertainties are multiplied by constants, you have to multiply them by a constant before you add them. Okay, I hope this makes sense. And I have another example. Okay, the plan was to stop the video here, but let's do one more example. Again, it's from a past paper that I haven't written down, so let's call this example number 2. Okay, therefore this would be example number 1. Okay, all right, so we have this quantity n given as 1 plus d squared over 8 times I cannot read my own handwriting, so t times f. Okay, so for some reason I solved for n minus 1, which is d squared over 8tf. Okay, now d is again some length given as 5.02 plus or minus 0.02 centimeters. Then t is 4.28 plus or minus 0.01 millimeters, which I converted to centimeters by dividing by 10, so 0.428 plus or minus 0.001 centimeters, and then f is 11.6 plus or minus 0.2 centimeters. If I'm not mistaken, this must be some index of refraction of some sort. But anyway, that's not a big concern. So I guess the first question would be to find what n is. So n is 1 plus the quantity, all these quantities work out to 0.634. So we have 1.63, so I'm pretty sure that this must be an index of refraction. Okay, so to find this, you just take this squared and then divide by 8 times t times f. Okay, and we probably have to find the percentage uncertainty in n. Okay, so the task is to find the percentage uncertainty in n. Okay, now the percentage uncertainty in n minus 1, okay, which is this quantity over here, will be the percentage uncertainty in d squared plus the percentage uncertainty in t plus the percentage uncertainty in f, because when we divide things, we add their percentage uncertainties. Now the percentage uncertainty in d squared will be 2 times the percentage uncertainty in d. So this is 2 times 0.02 over 502 times 100. So that's 0.79%. Okay, the percentage uncertainty in t is 0.01 over 4.28 times 100, so that's 0.23%. And then the percentage uncertainty in f is 0.2 over 11.6 times 100, gives 1.72%. Okay, now the percentage uncertainty in n minus 1 is simply the addition of all these of these three, so this, and that, which gives me 2.75%, so about 2.8%. Okay, I rounded it. So the absolute uncertainty in n minus 1 is 2.8 over 100 times 0.63, which is 0.001 0.018. Okay, because the reason why I solved for n-1, now I remembered it, is because 1 is a constant. Okay, so if you need to find the percentage uncertainty in this quantity, which is given in terms of measured quantities. Okay, so we found this over here, and then we find the absolute uncertainty by multiplying with the value itself, and the value itself is 0.63. Okay, and the last step is to find the percentage uncertainty in n by dividing the absolute uncertainty. And again, the uncertainty only comes from the measured quantities, because n is given by the addition of a constant, and the constant has an absolute uncertainty of 0 pretty much. Okay, so the percentage uncertainty in n is 0.018 over 1.63 times 100, so 1.1% is our answer. 1.1%. All right, so this is my video on uncertainties. I don't know if I'm going to upload more videos related to Unit 6. This is all you need to know in terms of uncertainties, pretty much. Now, as far as the core practicals go, when I taught this class, I showed videos and simulations of experiments, not really the experiments themselves, because I didn't use any equipment, okay? But I will keep thinking about it. But for now, I hope this uncertainty video helps. Let me know what you think about it in the comments. If you have any questions, ask in the comments. And please like and subscribe and so on. Hope this is useful. See you in the next video. Bye.